Okay.
Try and... I have a microphone. Excellent. Hello. Great. Welcome to React London. I'm absolutely delighted to have everyone here at The Guardian. Just some bit of housekeeping to go through first. So the Wi-Fi passwords are up on the walls. If there is a fire alarm, we're not expecting a fire drill. But if you take the same route that you came into the building out, and then we'll just assemble by the entrance. If you're looking for the restrooms, if you go out through one of these two side doors here, they're just down the side. And if you have any questions at all, could all the Guardian developers in the room raise their hands, give us a wave? Brilliant. So if you want to know anything at all, just find one of those people and they should be able to help you out or point you in the right direction. And now I'm going to hand over to Etienne. Oh, one last thing. Phil, are we hiring? Yes, we're hiring. So yeah, find a Guardian developer if you want to know more.
Thank you. Hello, good evening. I'm Etienne. I'm a software engineer for Red Badger, and I'll be your MC tonight. Firstly, I would like to thank you, The Guardian, very much for hosting us tonight. I would also like to apologize for the pizza being a little bit messy. Some announcements before we begin. Do tweet in our hashtag. We have a React London hashtag. We also have a React London Twitter account. So if you want to have more news about the following meetups, do follow us. We're also organizing a conference on React. It's gonna be next month, Amy? March the 28th. Sorry about that. So yeah, if you want more news about that, check our Twitter account or react.london. And well, I guess that's all. Let's start. And so I'll introduce you John Yardley, his tech lead with us at Red Badger on the Fornums and Mason project. And he'll tell us all about React with an introduction talk. Thank you. Please, a round of applause.
Hello. Yep, brilliant. Ooh, thank you. So I'm here today to give you a talk about, it's a really basic introduction to React. Can I have a show of hands about who's tried React, who uses it in production? Wow, okay. So hopefully this won't be too boring for you. But yeah, basically this is just a React 101. So my name, as Etienne said, is John Yardley. This is my Twitter handle if you want to troll me afterwards. So we're using React for about 2.5 years, and the project that I've been working on at Red Badger, we've been using it for just over 3 years. So, you know, we were using React from the very beginning, and we've learned a lot, hell of a lot along the way. And also, as it's been evolving, we've been moving alongside with it and trying to modernize our code base with the changes of pace and best practices, which I know that Marcel will touch on later on. So I work at Red Badger. We make things better. I believe we're hiring, so come and speak to one of us later if you're interested in the job. Sorry, The Guardian. So we're a digital consultancy based at Old Street, and like I said, we've been using React for about 3 years. Yeah, I mean, we've been using it on a wide number of projects. So although a lot of you know what React, I'll go through a bit about what it is and what it isn't. So React is essentially just a UI library. It's not like Ember or Angular in the way that it tries to dictate or is very opinionated in the way that you build your applications. It is essentially just the view in MVC, even though it's not MVC at all. It's just a view layer. It allows you to look after all the other bits of your application independently and how you want. It was developed by Facebook a couple of years ago, and you can use it for static or dynamic applications. So you can render it on the server instead of static content, or you can render it on the server and then also make it dynamic on the front end, or you can just run it on the front end and have something else serving your applications by the server. I suppose the one key thing that's come out of React is that it makes us think about components. I know for a long time in especially front-end development, there's been a sort of a search for the holy grail in modules and modular development and making sure that everything's sort of encapsulated into these little blocks that we can reuse and compose. And React sort of forces us to think down that road, and I'll come on to that in a little bit. It's super quick, and that's because of the way that it applies updates to your view, and I'll go over that as well. It encourages immutability. So unlike the old days of the classic backbone and marionette partnership that a lot of us will probably have experienced at some point in our time, there's a whole load of messy binding and unbinding events, and trying to manage all of that things creates loads of nasty side effects and bugs that took hours and hours to get over. And React makes us think about our applications in a different way, which results in less bugs, and it means that it's way more testable. As I mentioned before, you can render it on the server and the client. So what React is not, as I said, is an application framework. It doesn't manage how you fetch your data. It doesn't manage your application state. It doesn't dictate really how you structure your application in terms of any sort of side effect interactions. It's just a view layer. It even it doesn't even dictate the way that you manage your styles. So it gives you a lot of freedom, but it is sort of opinionated in a very small way, and that's just to do with the way that it renders code. So let's talk about application state. I think that application state is one of the most complicated things in modern application development. As your application is growing, you've got these bits of state which are dotted everywhere, and the reason why it's complex is because your app has to sort of react to state change. And it's our job as developers to make sure that when the state changes, that we reflect that in the view for the user. And if you've got a big complex state tree or state all over the place, when that's changing, it's really hard to catch all the edge cases. And it becomes very, very difficult. And React has changed the way that we think about that. So if you think of your view as a projection of state, this is React on a very simple level. Essentially, when you construct your React application in components, you're just running a function. You stick your state in, you run a function, you get a view out. And every time your state changes, you re-render the whole thing. Well, sort of, but you can sort of imagine it as re-rendering the whole thing. It does some very interesting stuff in the background, which I'll go on in a second. It's much easier to reason about your application, and because it's functional, you can move all your side effects to the edge, and you can prove for every component that I'm going to give it this state and this is going to happen, and it makes it much easier to test about. I mean, you can have stateful components, but they're easier to test as well than previously. So components. With React in the view layer, everything is a component, and there are different, people talk about higher order components and, stateless components and stateful components. I'm not going to go into all those details, but everything is a component. So for example, this is from the Red Badger website, and this is how you might split it up into components, right? So you might have a header, and then you might have a message box and an input field and a submit button, and then you could wrap that into a higher order component. And you could even put an interstitial component to wrap that form into its own component. So this is what we're talking about when we're talking about view components. The other thing that makes React really good is its rendering speed. So I know it's not the fastest out there, but it is one of the fastest, and was one of the fastest for a long time. So as I said before, your view is a projection of your state. React doesn't just re-render the whole application every time your state changes. It uses what's known as a virtual DOM, which is it's basically a headless version of the DOM, which is the document object model. There you go. And basically, it does this diffing thing underneath the hood. So when you make a change, it re-renders a tree in the virtual DOM and then does a diff, and then only changes the bits that it needs to, which I'll show you now. So the DOM, for those of you who may not know what it is this thing on the right yeah, right, the right-hand side, which you'd use every day if you're a web developer, just to like, navigate through the documentary. This is what I'm talking about. So to make this a bit simple to reason about, if I have a tree, so you've got A might be your body, and then B might be header, and C might be some like main content, and you might have something else underneath. Let's say that you change. Let's say that you changed something in C, which affected E. What React will do is work out the difference. It will re-render it in a virtual DOM against your current DOM, compare the two, and because you've changed something in C that affects E, it will re-render those two and leave D on its own. So it's really, really effective at rendering those things, and even that goes down to things like attributes, class names. Like, it's very, very granular in the way that it does it. There's a whole load more literature on this, but this is just like a high-level overview. The other thing that JSX introduced, React introduced, was JSX. Essentially, JSX is a preprocessor for JavaScript, which allows you to use XML inside your JavaScript files. And when I saw this first, I really, really, really hated it. And the idea of putting HTML in a JavaScript file really freaked me out. But actually, as I've been using it, you understand the value of having your representation of your DOM next to your application logic for that component, and then we're coming into CSS in JavaScript now as well, which is taking that an extra step further, so your modules are actually really, really modular. And then we use tools like Babel and Webpack to convert these and then package them up into JavaScript bundles, which you can serve from a CDN to your application on the front end, and you can also use those to render your application on the back end. So essentially, JSX looks like HTML, but it has some very special properties. So for things like, so the top example here, you can execute JavaScript inside your in your JSX by using curly braces, and then you can use variables. You can even do string interpolation as well. And some more examples. So in JSX, and especially with React, so class, you need to use class name, because class is used, I think it's, I'm not entirely sure why actually, but you use class name to say, oh, this is going to be my class. And you can use it for your on-click handlers or any sort of event. And then as well, you can set traditional parameters as well. And they're all camel case. So if things were sort of hyphenated in the old school way of thinking, we just make them camel case. And this is how you would render a component, like a custom component you've written. So if you wrote a component called myLists, and you wanted to pass it some information, which then you can render in that component. I'll show an example of that in a second. You can create what's known as a prop or a property called list items, and that would pass down items, which could be an array, it could be an object, it could be a string, it could be whatever. Okay, so I'm going to give you a quick demo, hopefully. So the plan is here to create a React app from scratch, all going well. So I'm using Create React App, which is a really good starting point. So there's a sort of a barrier to entry when using React, I suppose, is that the fact that you need to like set up Babel, and you need to use Webpack to bundle your things, and you decide, hey, there's a whole like thousands of, this JavaScript fatigue that people keep going on about. There's a whole load of that. And what these guys have done is just create a really simple way of kicking off your app. This is something to use to hack with, or like to have a play about, but I would not use this in production. But to get you started on how to use React, it's a really good tool to use, because you don't have to think about any of those things. So I have prepared earlier, I've downloaded this. So actually, can you see my, here we go, this is probably a bit better. Is that big enough? A bit bigger, perhaps. So you can install create React app there using this, and then you can just run create React app, and then it will create you a folder, down all the packages and dependencies, and then set you up with Webpack, Babel, and it also includes hot reloading, which is really useful. and a bunch of other stuff, which makes it really easy to get started with. So in here, I've already downloaded this. Okay, so the first thing to look at, I suppose, is the HTML page here. So this is just a client-side application. Oh, you really can't see that, can you? Let me see if I can change to a lighter theme. Sorry. Here we go. Let's use that. There we go. That's better. Okay, so essentially, it's just a HTML document, as you would expect. And the only important thing here is that you give yourself a div or whatever that has an ID which you can access. And inside there, like many other frameworks, your React application will be injected into. And so if we go into the main index file, you can see here that we import React, and then a thing called React DOM, which has allowed us to inject things into the DOM, and you can use this on the server as well. And then what we're doing is basically we're just saying inject this this component called app into the root, and then if I run npm start here, should have a running example. So this is what you get out of the box if you download this. Let me just minimize this, put that here. Okay. Yeah. Okay. So I said before, like JSX is much like HTML, so you can just put in hello world here. I'll read as a page, and we've got hello world. So you can pretty much put anything in here, but I'm going to revert that to app and dig a bit deeper into here. So I'm going to delete that file because we're writing this from scratch. So the first thing you want to do with any React module or component is import React from React. Now there are ways in I think with Babel to just include this globally, but for now we're just going to import it because that's not set up by default. And then what we want to do is just create a function, right? So we're going to have a function which spits out some JSX which says hello world. So we'll create a function called app, which is a self-returning function that returns some world. And then export that, export default app. So that's our first component, right? So all a component is, like I said before, the view, or a component in this instance, is a projection of your state. Although we've got no state going into it, it's still a function that just returns some HTML, which says hello world. And so what about if you wanted to pass some properties or some props down into this component? So we can do that, as you saw here, by, say, passing down a prop called name. And we'll just pass a string, guardian. Obviously, nothing's changed here. But this is the sort of application state, or the properties that get passed out into this application. And then I can use some JavaScript injection here to put props.name. And then we get hello guardian. So that's a really basic example of how you can use that. And so if you wanted to create, so let's turn this into a header module. So it's good practice. Marcel will talk a bit about this. So creating a folder. Oh, yeah. So let's create a components folder. Components. And then we will create a file. Actually, that's in the wrong bit. And then create a header component. So we call it header.js. And then I can pretty much copy this into here, change this and this into header, and then to import a component into a high-level component, we can just put header from components, header, and then we can just use header. Oh, okay, brilliant. And then we also need to pass in the name, which we're getting from props, props.name. Okay, and so you can see quite easily how you can start abstracting things out and start building components and passing properties through. So I suppose one of the easiest thing that people do is create a list, and that's quite a common thing to do, to create lists of things. So I'm just going to go through a quick example of that and show you some more features with React along the way. So let's create a list component file. Okay. First thing we do is import React from React. And then we're going to create a function called list, which is a self-returning function, which has a UL, and we'll have a couple of list items, right? So 1, 2, 3, then export default list. Cool. And then we can import this into our app here. So one thing to note about your JSX is that you need to have like a wrapper div if you're going to have more than one child. I think they're fixing this in a newer version of, I think, the next version of React. But at the moment, if you want to have multiple child or sibling components or elements, you have to wrap them in a higher component. So you just have one parent component or element. And in here, we can put list, and then we can import our list here. A list from components, list, and we have our list. Okay, so that's all great. We've got a static list. That's pretty boring, pretty dull. So what we would actually want to do is be able to drive that from some data. So perhaps we had some items which were an array of numbers, and we wanted to turn that into a list of things. So we can use this curly brace notation, and we can do items.map, which is, is just a method on an array. And I can say item, with that item, I'm going to return a list item, and I put the item in there, and it's the same thing. But then I can, add more data elements to this, and it will drive that thing, drive the list on the right-hand side. Okay, cool. So actually, like, what I want to do is, in most cases, I want to interact with this list and add more things or remove them. So I'm not going to go into the whole shebang, but I'll just show you how you can turn this. So this is what's known as in the React world as a stateless functional component, in the fact that the function itself has no state contained within it, although the application has state, which are normally passed down as props. The component itself has no internal state. So you can test it in a functional way. It's pure. But if you wanted to use some internal state to be able to manage, like, adding new things to the item, we can do this by turning this into a what's known as a stateful component, or what React exposes a class called component, which you can extend from. So if we add this to our import, we can quite easily. So we want to create a new class called list, which extends from the component class. And the only thing we need in a component class is a render function. So we can create that, and that needs to return some JSX, right? So we can just copy this in here. Cool. You can delete that, stick that in here. There we are, and that all works. So we've done nothing different apart from that this class component has a bunch of lifestyle methods on it, which I'm going to cover in a little bit. But I'll show you now how you can turn this into a dynamic list and add more items to it. So we talked about, like, internal state, and the way to add that is you need to create, because this is a class, we need to create a constructor, right? And constructor, is that right? I think so, yeah. So the colors are off. So just like the functional component, the constructor for the class takes some props. First of all, we need to do is to pass those props up to the super method. That's just like a thing you just have to do because React does some funny, cool stuff with it. And then if you want to add some state to this component, then we can attach some items and we can say that's an array. And actually what we can do here is we can say that that is driven from the constant that we set up above. Right. So let's just say that's 1 and 2, and then hopefully, okay, so that's actually not driven by the state, it's still coming from this list constant at the top. What we can do in here in the render method is to create a new constant called items in here, and this can be this dot state dot items. So it's this because we want to get the state from the instance that the class creates, and then we want to get state and then items. So for example, if I put in here like A and B now, so this is coming from the component's internal state rather than anything from the outside world. So let's get rid of that now, we don't need that. So I'm going to go back to some numbers just to make this a bit easier. Okay, so the next thing we want to do is add a button. So that's quite easy. So we need to create a div because you can only have one parent component. And then we want to add a button here, add item. As you can see on the right, we've got a button, although it doesn't do anything yet. So adding event handlers for things like buttons or input forms, pardon me, is really easy. So we can just create a method on the class called handle click. Yeah, that's right. Which is a method that doesn't return anything. And here we can just say alert, boom. Okay, right, and so in here then we can add an on-click handler on the button, which again is this because we want to access the instance method of this class, and handle click. And so now when I click this button, you should get an alert, which is boom. So one thing to note here on the click handlers is that this doesn't, like as you're probably aware, this doesn't attach the click, it doesn't bind the click event onto this element. It like bubbles up right to the top of the stack. So all of them are handled right at the top of the stack. And the other thing to note is that the events that you get from these events are not they're not browser events. They're like these things called synthetic events, and they're normalized across all browsers. So you don't have to worry about browser inconsistencies. So you can always get like event.target.value, and it will be the same, and loads of things for a load of other properties as well. So it makes actually like handling events and UI events really, really easy. So say when we click the button now, we want to add a new thing to the list. We want to update this state. So React comes with, the React component class comes with a method called setState, which obviously makes sense. This does partial updates to the state. So if I had, for example, here, like a label is home. If I update label here to say not home, it would only update the label bit of the state and wouldn't touch the items. It would just leave it as it is. So that's quite good because you can imagine having lots of different click or event handlers which update different parts of the state for that particular component. But we won't go into that right now. So first thing we'll do is we want to set this state and we want to add a new item. So the first thing we want to do is to set items, which is in the state here, and we want to give it an array. And here, if you're using the latest JavaScript, if you're using ES6 and ES7, I think it's ES7 actually, and you can use a spread operator to deconstruct that array called this .state.items into your new array, so you're immutable. And then we can just do this .state.items.length +1. And what this will do now, so when you click on the add button, it will run this handle click function, and then it will update the state with an items property, which will have an array of all of the previous state items plus a new one, which should increment in 1. That's the most exciting thing that's happened to me all day. Trust me. Cool. So I just wanted to give you a quick round robin of the different ways you can use React. So if you go back to this component here, this to me is what React is all about. Like we're trying to rewrite an entire code base that's been around for 2.5 years, nearly 3 years. And somebody made the clever decision to write it in LiveScript originally. So we're trying to re-engineer all these things. But we found that stateless functional components are the way to go. And actually you manage your state somewhere else. And Caddy's going to talk about Redux in a bit, which is a good option to manage your state. But these things are genius because you can test these so easily. You know that what you put in, you're going to get out. So definitely do this. And in the cases you do need to use stateful components, they're also great. And there are tools that you can use to test those really well as well. Right, so back on to the slides. Where is that? Here we go. So, cool. So I mentioned briefly about the component lifecycle, and stateless functional components, like the header that we just built, doesn't have any lifecycle methods. It just has a render. It just returns what you give it. But the stateful component class that you can extend from does. So again, the constructor is stuff that you want to do before anything else. So you get some props in. If you want to modify those and set your state, you do that all in the constructor. Component will mount. Basically, React says this component is going to be rendered into the DOM. Pardon me. And this is, you can do things on the server in this as well. So if you're rendering this on the server, you can do some stuff like maybe fetching some data then to put into your state. But yeah, that just triggers before it gets mounted. Then your render function happens, which just renders your JSX into HTML. And then component did mount. This is very useful if you're going to use things like D3 or SVGs, or if you want to be really 98 about it, you can use jQuery. But you can use that to get elements from the DOM and then use jQuery libraries to hook that all up. So when you want to update a component, so if you've got a component which is higher up, which is changing the props coming into a child component, you get, you can call this, you can write some code in this method called component will receive props, which is before any updates happen. Should component update, you need to be really careful about, because if you override this in the incorrect way, you could actually have an performance implication in your application. React does a really good job of trying to improve performance for your rendering, but this is for if you're trying to achieve super optimal performance in something that's quite heavy with updates. You might want to check to see if the component actually does need to update before it tries to update it. And obviously component will update means it's about to be updated. The render and did, obviously the same as before. And then, for example, if you did use D3 or SV, if you did any SVG manipulation or any jQuery or external libraries, you probably want to tidy up any bindings that you did with component will unmount. And that's if, for example, if you're removing item from a list and the item's in a subcomponent, it will call this method just before it removes it. Cool. So where to go next? So application state management is probably one of the hottest debated topics around React. That's quite a hard thing to get right, and Kelly's going to be talking more about that shortly. Client-server communication, again, that's another thing that's, there's a lot of things, there's a lot of different ways of doing things, but there's a whole discourse going on about that at the moment. And server-side rendering is something that's really cool because then you can truly have the same code on the server and your browser and not have to worry about it too much. And then there's a little bit of a let me Google that for you slide where, so the top one, React Docs, really good. Build with React tutorial is actually a really good tutorial to get you started with. Create React app is a great way to just get started and not worry about any of the setup stuff. And Awesome React which was just has like absolutely shitloads of stuff on here, right? So if you want to go and look at anything to do with React, it's all here. So that's like the React Bible. Cool. Thank you. Any questions?
You've got about one slide so I can take.
Yeah. I'll share the slides on Twitter anyway, and I'm sure we'll retweet them from React London. But
Any other questions?
Why wouldn't you use Create React app in production?
So it makes a lot of assumptions for you, actually. But actually, that's a good point. I know. I think it's much better to like set up everything that you want in your own way. Like it's very opinionated in the way it does stuff, and it probably includes more than you might need. So it's worth like learning about how Babel works and how Webpack works, so that you can really optimize your packages that you're distributing to your users. That's what I would say is not use it for, because yeah, it might include a load of stuff that you never use, and you'll be just like throwing a load of weight at your users, which is a bit unnecessary, especially if they're mobile users.
Do you know how the React affects SEO?
Okay, so if you render your application server side, it's just HTML. So like Google and Yahoo and Alta Vista, if that's still floating about, will come and pick that up. In terms of, instead of client-side rendering, I suppose it would be the same. You'd have the same problems with Angular or Ember. And actually, like I think Google does do some clever stuff to try and pick that stuff up, but I can't speak for the other engines. But especially if you render server-side, like it's going to be fine. And when you render server-side, you render your HTML document entirely with some props or some state, and then once the document's loaded, React just kicks in and says, okay, right now I'm taking control from the UI perspective, from the bundle that you give it from the UI. But yeah, I think it's all really good. No, I mean, we've had no complaints.
Any other questions?
Cool.
Okay, a big round of applause for John, please.
Thank you.
And now I would like to call Marcel Kutz, also known as Mystery Marcel, one of our software engineers at Red Badger as well. Please, a round of applause.
Boom, boom. All right, I'm going to do something very important first and get a beer. Talk amongst yourselves.
Hang out as usual.
Oh, yeah, sure. No worries. All right, everyone. Grab your beers, sit down. Yeah, I know. I'm entirely to blame for this. I take all responsibility. All right. So, first of all, for the first time in my presenting career, I have a clicker, and this makes me really excited because I can walk about for once. All right. My name is Marcel, and I'm going to be talking about best practices in React. So first of all, I want to clear up a misnomer. Best practices is a very loaded term, when really it's more like best practices. It's a collection of opinion that people have sort of come together to agree is the right way of approaching things. But if you're doing something that works for you, if you're doing something that works for your team, something that makes you happy, something that makes you productive, and I say something different, don't throw it away. This is just a collection of ideas on common topics that I think you might find useful. I think people only really consult best practices when they reach a point in their application development where they don't know specifically what to do. They're worried about the choice they're going to make, the long-term maintainability of that choice, the complexity it might introduce, and they try and consult what other people have done before. And these are generally grouped into best practices. So I'm going to talk a little bit about how to structure your application. I'm going to talk a little bit about styles. I'm going to talk a little bit about testing. And I'm going to talk a little bit about tooling that can help you make good React applications. Right, so this is kind of geared towards people who have done all the to-do MVCs and all the other tutorial things, and are starting to make the first real React application. And you start to have all these big questions that aren't really answered, like, how do I structure my application? Where do I put my folders and stuff? In Angular, I used to group my directives all in one place and controllers in another, maybe. Well, if you're having a simple React application, you can also keep the structure pretty basic. So you have a place for your components. You might have something called pages or views, which is just a collection of composed components that you could route to. And maybe a services folder, which you might keep things like API logic in, or something else, some sort of utility stuff. Fantastic. And index.js as an entry point. Cool. So that's how we have a top-level overview of our application. What about our component tree itself? Well, try and keep it flat as possible. It might be tempting, once it gets quite long, to start having components live in component folders, having a sort of more tree-like structure, but try and avoid it because it betrays the intent of components. Components should be usable and composable by themselves or with others. By structuring them as always as within the folders of other components, it gives the idea that they're somehow coupled, and you might start to betray yourself by coding them that way. The list might get quite long, and you might get this like big component zoo, but that's good. You can always use search. And if you name them well, everything's good. Okay, what about our components themselves? So components should be self-contained. Everything you need in a component should cohabit. Ideally, if you're doing everything right, you should be able to take your footer component, rip it out of your project, chuck it over into someone else's tree list of React components and go, here, you can use this too. We have our actual component code, we have our test to make sure it behaves, and we have our styling on it. And that should just work anywhere. And it should be self-contained. If it's a footer, it should look the same everywhere. If it's a child or something, if it's by itself, if it's in an array, it doesn't matter, right? So this is a very different way from like the big, jam-packed, often very coupled way that we used to approach things, especially with the sort of jQuery spaghetti that I'm certainly guilty of having made at some point in my life. Cool, so we've got some components. What next? How do we actually write a component? So John, in his rockstar way, has already touched on it a little bit. But there are three main ways of writing classes, of writing components. You can have the class method, you can have the functional stateless method, and you can have something called the create class method, which you might encounter if you pick up a legacy project. So we'll talk about it briefly. All right, so this is probably the most common one you see nowadays. It's a React component that extends the component from React itself, and you have a render function that just returns some JSX, so just renders a HTML with a little child component. It's all good. It's very simple. It needs a bit of Babel because of the JSX, of course, and for all these import tables and stuff, but pretty good, fine. Testable, understandable, but if you can, Functional components is where it's at. So stateless functional components are amazing because they have even less magic than extending class, which is fantastic. They are very easy to read, they're very concise, they're extremely testable because they can be very, very pure. They're just amazing. And as time goes on, they're going to get more and more performance. So it's really important to have this. Plus, writing them in this way is a really good habit because it forces you to think of all these components as pure and dumb in the center and push all your side effects to the edge so we can get closer and closer to the shining white light of functional programming, away from the 30 years of darkness of OOP that we've all been subjecting ourselves to. You all know what I mean. Right. Okay. So this is fantastic. And you might think, okay, sometimes I need lifecycle, sometimes I need click handlers, sometimes I need state. You do, but there are ways of still using pure components and having those things through tools like Recompose. That's a little more advanced, but if it's something that interests you, Google it. It's fantastic. You can make very large, complex React applications and never use extend component. Okay. So now for the grumpy old way of making React components. Create class. This was made in the era before we went all ES60. It's still around in places. I think it's still valid syntax, but it is definitely on the way out. You can see that we use a special method to create this object where we then define all the bits and pieces we need, like lifecycle methods and render and whatnot. Don't use it. It's a pain to test, it's a pain to write, it's a pain to read, and it does also render 15% slower on the server side, so don't do it to yourself. But yeah, if you see this in the wild, think about gradually changing it. And there are tools out there that try and automatically do it now for you as well, so they're pretty good. Cool, so we're writing components, and that's all good. But at some point, oh yeah, this is the hierarchy. Functional components are the best. Class components, pretty good. Create class components, die in a fire. Right, let's talk about one of my favorite things. And by favorite, I mean, keeps me up at night. Right, who here has ever been frustrated by CSS? Stick your hands up. The rest of you are lying. Right. So styles are hard. Like, let's just think about it for a second. We've always got to consider browser differences, viewpoint differences. We've got to think about performance considerations between different browsers and how that might affect people on different devices and that sort of thing. Oh, God. And then there's the naming conflicts and the cascading nature of styles, and it makes it so hard because the nice encapsulated component system where you have your Lego blocks and you can make your UIs and everything is encapsulated is great, except CSS doesn't want none of that. CSS is cascading style sheets. And it desperately wants to bleed from parent blocks to child blocks and ruin your lovely ideological approach to creating views. I mean, it's not really CSS's fault. CSS was created in 1996, making it 21 now, which means it's old enough to drink in America. And, you know, it's evolved a lot over the years, and nothing's consistent, and the spelling's all in American, and, you know, we use it because we have to, not because everyone thinks it's a good approach to how we would make styles nowadays. Cool. But let's be clear. I don't care if you use less Sass or just CSS straight away. It all ends up with CSS in the end when the browser reads it. So we're talking more about how we manage the behavior of CSS rather than the actual particulars of technology. Cool. So we've been trying to make steps to control the rapid cascading nature of CSS for ages. And one of the first and most common things out there at the moment still is BEM, so block element modifier approach to writing styles. So what does this mean? Well, if we have our simple React component, here just a little form component, we name everything in a block element modifier model. So at the top level, there's a block, and then everything else has the block and then an element name if it's like an input element, or something even more complex if it's like a submit element and it's got state. So the great thing about this is you can have these very, very flat CSS bits. And this means, hopefully, because these should be unique, you're never going to have naming conflicts where something class big in the parent overrides or extends something class big in the child, because simple form will be in front of it, and there'll never be another simple form component because we name our blocks after our components, which have to be unique. Okay, that's cool, I guess, but it's a bit ugly to read, and it requires that there is no human error ever. And I'm an extremely lazy person who doesn't want to have to think about messing up. So then came along CSS modules. And I think, although this scene is very much in motion, this is the best approach currently available. It's extremely battle-tested, extremely popular. There's lots of help in the ecosystem. And basically, what we do here is we use a little bit of back magic and import our styles directly from the cohabiting style sheet in our component, which means that we can directly import the bits of the styles we need to the elements that we want to style. Hooray! And the good thing is, we can now write regular CSS again without having to have all this additional faff of discipline and memory. And you know, like when you want to refactor something, you rename a component, now you've got to rename all the styles. Here you don't, because of CSS modules, because you can just use regular names. And when you set table here, it won't set table on the children, because when it's done all this magic in the background, it'll have done all these sort of scary hashing and unique class making for you. But for developers, it's still readable. It is a much better developer experience. It's much safer, and it's generally just better. Okay, so that's great. And we've kind of done a bit of work to make CSS a bit more manageable in our new component overlordy ways. But watch this space, because there is a huge battle to essentially wipe out CSS completely, if possible. We don't really want to have to think about this. So CSS in JavaScript, a huge thing at the moment. There are so many approaches, lots of very interesting novel stuff. We already have HTML inside our components in the form of JX, so why not our style as well? That being said, it is still very much up for grabs. So here's a nice list of the currently competing CSS and JS libraries. Pick your favorite. I have a bet running on which one I think is going to conquer the rest. We'll see how that goes. No, I want to know your bet first. Oh, strong choice, Styletron. But if you want to talk to the guy who made style components, come to the React London conference in March. Max is a lovely guy. Cool. I think I have to go back, right? Hey. All right, cool. So we got our structure sorted, and we got styles, and we think all this testing lark is something I should probably do, because otherwise Kent Beck will laugh at me and send me mean tweets. So, all right, let's think about testing. If you Google testing and React, then you might well be bombarded by a fair number of choices, and you might be a bit overwhelmed, because there's a lot of stuff. And you think, which bits do I need? What do the different bits do? Some of them do the things that other bits do, and some bits don't. I think if you're just starting out, a solid combination that'll see you through most things is Jest and Enzyme. Now, Jest used to be a bit naff, but it's great now. So give it another chance if you were disappointed before. Essentially, since about version 13, Facebook have really thrown their weight behind Jest and made fantastic improvements. And we'll also need Enzyme, which doesn't have a logo. So enjoy this text. Okay, so Jest gives you a lot of things. It gives you a way of running tests. It gives you a way of mocking. It gives you coverage tools. It gives you a lot of performance because it parallelizes for you. It has a nice syntax. It's easy to understand, and has some very developer-friendly watches as well. Enzyme lets you render your React components in a shallow way, which is very important. So by shallow, we mean, let's say you have a component that has children. It'll just render completely the top level component and not the children completely. This means that you can render each and every component in a shallow way, which is very performant, and you have no excuse not to test each and every component. And that's why each component should have a cohabiting test. Great. Okay, shall we test some stuff so you can see what it looks like? So thank you, John Yardley, for warning me about the whole brightness thing. I have now changed my atom to the brightest possible white. Cool. Okay, so we have a super simple function here of just something that adds things together. Hooray. And we want to make sure that it adds things together properly. So what might a test for this look like? It might look like this. So we have our summing function, which is fantastic. We have a test to make sure that 1 plus 2 does equal 3. And for most of you, this will look very familiar because this is very similar to the Jasmine syntax that most of us have been exposed to at some point in our lives. And this is because underneath the glorious, shiny overcoat of Jest lives Jasmine. So all those tips and tricks you have aren't completely at waste now. Cool. All right, well, let's run the test and see what it looks like. Yeah, that's reassuring. Cool. So yeah, 1 plus 2 equals 3. It's fine. We're going to make sure it fails sometimes too, right? Glorious. Okay, and as you can see, it gives you lots of helpful hints. So it's not like many test runners where they just give you like a line somewhere and you kind of have to figure it out for yourself. It does do quite a lot, telling you how you evaluated, what it expected, what it received, and it's got quite a nice layout. And it's very useful when you're developing. Okay, let's do something more advanced. Let's test a component. Specifically, let's test this component. Groovy. Okay, so I made this very quickly with the Create React app that was discussed earlier by the handsome John Yardley. And all it does is have some text that changes when you check this text box. So we're all good. But we want to test in a unit way that this is the behavior that happens. All right, let's have a quick peek into this one. Cool. So we'll clear that. That ruins the surprise. Right. So at the very top level, we have this app, and we have this child component called label switcher. And we pass in these two props, label off and label on, which just defines what text we're going to be displaying in what state of checkedness. And if you look inside our component tree, you see the label switcher. We gonna scoot this over slightly. Okay, cool. So we have nothing too complicated. We have a label switcher class. We have state, that is whether or not it's currently checked, with a default state. And we just have a little bit of input. That's a checkbox that say, hey, you know, whatever the checked is related to the state that we defined above. And when that state, when someone interacts with it, change the state. Great. And then we have different strings as evaluated by this expression. So if it is checked, give the label on, and if it's not, label off. Great. Cool. So now we want to test this. So if you look at our test, I'll make this slightly smaller. I'm sure you can still read, right? Is that still readable for everyone? Nice. Fantastic. All right. So we have a number of tests here. Firstly, we want to text that, like, in an unmanipulated state, it shows the correct thing, the label that we expected. And it's just an equality check. What it does, though, and this is the enzyme bit, is we can use shallow, which we import from enzyme up there, to render just our checkbox label component by itself. So we use exactly the same JSX syntax, which is also why we have to import React at the top, by the way, because otherwise JSX is very unhappy. And we can render it exactly, and we can then just navigate its sort of pseudo DOM and get stuff out of it, like text. Hooray! So let's just try running it by itself. We'll comment out all these other tests, and we'll do a bit of MDMT. You can also use yarn T if you're a bit more hipster. Cool. So there are some other tests in this application, but we can now see, like, okay, all these are passed. And if we were to change one of these, you can see the watcher automatically reruns and tells you, oh no, something's gone wrong. So this watcher is actually very clever because you can filter the test you want to run by a regex. You can also just trigger a test run again manually if you want to everything. But it will watch and it's very performant. So if you're writing code, or if you're writing tests, which is also code, but you know what I mean, you can have this running all the time, and it will be very informative and not intrude on your overall performance. And it's a very useful tool to have. Yeah, cool. So let's put that back in. Let's make that work again. Hey. And let's add another test where we do something a bit more interesting. So we want to check that when we click that checkbox, the state of the checkbox with label changes. And that's okay, because again, that's the top level component. It's not a state of a child component to worry about. So we, again, shallow render this. We check that the initial state is fine, and then we do a bit of a simulation. Because remember, all events in React are synthetic, so we can do this. And then check that the text has changed to the expected on value, which it has because it's all green. But if we were to change this and make this checked, you can see that it would be very sad. So this is a simple way of going about testing your React components, and it's extremely useful, extremely powerful. And it means that if anything would ever go wrong, it should be very, very obvious very quickly. And because you're using all these lovely, pure testable components, all these tests will be very easy to write and maintain. Okay. Oh, another cool thing it just does that I almost forgot about. Snapshot testing. So snapshot testing is something that used to be in Jest only, but they've recently split it out into other things. And you can now find it integrated into other test runners like Ava. Lets you render entire sections of a page, and it'll do a sort of compare for you, kind of like a more clever screenshot testing, which can be very useful in certain projects. Yeah, so that's super cool, because it kind of sits between unit testing and automation testing, and it's much more performant. So you can keep your automated end-to-end testing very small, because that has a tendency to grow and cause lots of brittle problems over time. Yeah, testing, eh? Cool. Right. I think. Are you a tab, or do I have to go back? You're a tab. Nice. Cool. All right, let's very briefly talk about tooling. So there's lots of tools that help you out in React. So React is a fantastic community and ecosystem. You can get all these amazing bits to make your life great, like Redux, which Caddy will talk about in a moment, but also all kinds of things like extremely good linting tools. If you're just starting out, I suggest that you get ESLint, which is compatible with nearly every text editor in the universe. I don't care if you use Wallaby, Vim, Max, Emacs, Atom, Sublime, and I mentioned Vim. It's okay. I won't get flack for it. Yeah, you'll be able to get ESLint working. And what it does is it allows you to set some rules to follow. And initially, if you don't know what you're going to be doing yet, a really good rule set to start with is the Airbnb rule set, which is quite strict, but will structure your code in such a way that it'll be very readable and consistent. So yeah, that's cool. Another thing that's really, really nice about React is the React developer tools. Man, I would have killed for this when I was developing Angular. Right, so in this tiny GIF, which I will live demo in just a second, so it's less tiny, you can see that when you have your React components, you can actually manipulate and evaluate and view the state of all your components, rather than just being this black box of mystery and desperately console logging 1,000 places to figure out what's happening to the state of your application. So if we were to quickly go back to that tab with the checkbox thing, and we look at a very trivial, oh no, is it too dark? we'll leave it for now. Actually, the React tools are white anyway. So all of my console log tools are completely dark and cool, except React Dev Tools, which doesn't have a theme switcher. All right. So if we were to inspect the label switcher, for example, we can see that it has 2 props, which we passed in earlier, and we can use this to update your props if you wanted to. Could you scale it up? Oh, yeah, of course. Is that all right? Perfect. No worries. Thanks for letting me know. Yeah, so you can manipulate the props dynamically, which is cool. And you can even manipulate the state if you wanted to. So clicking things that so last year. Nowadays, we only interact through website with the React Dev Tools. And this is actually incredibly powerful, although this is a very trivial example. When you've got a very large application with hundreds of components, let's say you're doing a big e-commerce site, and you're wondering why, like, oh, this coupon thing isn't working. I'm supposed to update this price thing somewhere, and you're desperately rooting around and putting console logs everywhere. Now you can just directly investigate the state of your application visually and explore it, and even manipulate it to see what happens. And that is so nice in comparison to the black box that web development often was in the past. We're trying to put debugger statements in and running through breakpoints very slowly. Yeah, and that makes me very happy. Okay, so I believe that's all I had planned for best practicing. But because best practices are only really sought when you have a problem, I'm happy to now take your questions on best practices. But remember, one of the most important things about writing any good application, best practice or not, is to have a really good understanding of clean JavaScript. And there's this fantastic GitHub repository of all these tips and tricks to write JavaScript that you won't hate yourself for later. Be kind to yourself, read this, and write code that future self will be proud of. All right, thank you very much. Who's got questions about anything best practicing?
Are there any security implications of that React debugger when it's out in production and people have that to manipulate things on?
I mean,
obviously they could do that anyway.
They
to an extent, but
yeah, I think it does reinforce that you always have to have server-side validation at all points. It does make it easier to peer into application than would otherwise, but as you said, you can always send a malformed post request to an endpoint and see what happens. So it's just, I guess, makes it more obvious that you can't scoot by going, I'm sure no one will ever do this. And maybe it's much easier to convince your bosses now to do it as well when you show them how easy it is.
So we're talking about CSS and keeping that in the same folder as a component.
Yes.
If you have multiple apps that want to share components, how do you handle that, or do you just duplicate across?
So if you have, I guess what you want to talk about is like having this UI component library. So you could extract that out into a third place and import that in. Perhaps there's some sort of NPM thing, and then the changes would be propagated across. But I would always be careful with these sort of things because we've tried these kind of things before, and another word for component reuse is coupling. So when you do update a component, you have to now think about the 2 places it might touch. So it's very dependent on where you see your applications going. But there are a billion UI libraries. I'm not entirely sure that are always a good idea because I think people end up being found bound to them rather than liberated by them.
We kind of find that sometimes anyway. So you say it's better to duplicate than to couple.
I think so. I think dry is not something we should die on a sword for. And I think that we should keep in mind that even if there is duplication, as soon as components start to be ingested in different applications, people will twiddle with them. So you have to then run tests against both platforms or N platforms if you are going to share these out.
Thank you.
Any other questions? Okay, thank you. Round of applause. I think we're gonna have a small break now before the next talk. So 10 minutes break. Yeah, take your time. And the toilets are over there. There are more beers over there. We'll be back in 10.
I know that that's useful things like, oh, you know, we don't have like this kind of yeah, we'll mix things like that, like two mixes of functions. Yeah. So you kind of do like just about like how we have so for example, you could make it global. That could be basically there's no reason why
Sorry, I'm plugging it again. But it's like my screen doesn't do anything with that. Yeah. It's working fine over here, so. Oh, guys.
Not screening properly.
Yeah, it's just phone coffee. Yeah, but we have some technical difficulties our screen.
I am. Listen, I have no idea. I've been here for 4 weeks. And I can't sleep at night.
Oh my god, same thing. In the summer, like it was like 3 months.
It's only to be 100 days.
Yeah.
It's a whooping cough.
Just a sec, it might be that one. You got it set to mirror? Yeah, it's coming up slightly different res on here though. It will do. I think if we get this to work, don't just don't touch it. Yeah, it's their stuff. Because they froze it for the.
Because like it froze even before Alex switched to mine.
Yeah. Well, it definitely knows it's going off to a screen, right?
Yeah.
It's just not picking up the screen.
So I don't think it's a problem with my computer because it's went crazy before Alex even switched to me.
This was just working just now, though. It's the same thing we just had all the other laptops in. So, just press that again.
It's very large now. It used to be very small.
I'll make it. Switch it over to if this can handle that. I hope so. Yeah, there we go. VGA, please. VGA, the blue one, please. The blue one, please.
So it prepares.
Do you want it mirrored? Or the presentation you view?
Yeah.
Right.
It's working tentatively. Did this wire?
Just try the clicker, don't touch it. Okay.
Start it again. All right, so for the next talk, we'll have Kadi Kremen. Will be giving us an introduction to Redux. Round of applause, please. Thank you.
Hi, and thank you. I'm sorry for the technical difficulties. So my name is Kadi. Oh, okay. Just a moment. Is that okay? My name is Kadi. I'm a developer at Red Badger, and I'm going to guide you through the wonderful Redux. We have a show of hands of who's used Redux before. Oh wow, those people. Wow. So for those of you who've never heard of it, from the website, so from the website, the definition for Redux, with the explanation that the one-line snippet that they give, is it's a predictable state container for JavaScript applications. And as a mathematician, I really enjoy this explanation because it's much like all the definitions in mathematics. They make sense, but only if you already know what I mean. So if you don't know what Redux is, I'm hoping that by the end of the talk, you'll have a reasonably good idea. So before I go into explaining what Redux is and how to use it, I think it would be useful to look at what's the problem that we're trying to solve with Redux. So as Marcel and Johnny Adri have said in their talks, what we want, ideally, in applications are these pure, simple, functional components. They have an input. Oh, you don't have my slides. Just gonna stay away. They have an input, and then they just have a defined output. They don't interact with anything outside of themselves. They don't retain any states. They're really easy to testable, easily composable, easily reusable. Unfortunately, in real life, applications aren't pure because the things we want to do with our applications are not simple. They're quite complicated. So if you imagine this was a UI for a storefront, you might have some like header stuff, you might have some store items, you might have some user preferences on the right, and then on the top right, you might have a basket where you have like, oh, I've got 3 or 4 items selected. And then all of this can be quite stateful. So usually what you do is like you have a containing component, and then you keep the state in that containing component and go like, okay, that's my dirty component, right? That can have the state. And then it just like passes on the state to the other components to like make them be pure. But what happens if 2 completely unrelated, like seemingly, parts of the application need to access the same data? So what if you need to add something to a basket and then display it at the top? What do you do then? Do you have like a global, do you have one big container? That seems quite dirty and quite difficult to manage. So that brings us to Flux. But you thought I was going to say Redux. So Flux is a pattern of state management, and it was developed by Facebook, like most things are in our lives. And basically, it's an idea of how we should manage our state. There is a Flux library. It's very lightweight with some tooling, but it's more like MVC or REST. It's an idea. You can choose how correctly you implement it. So in REST, we know that we should never have a 500 OK. I have seen it, unfortunately. And in Flux, the central idea is that you have one application state, which is managed in one place, and that is readable for anyone who asks. Anyone who wants to know, oh, what's the name of the user? Oh yeah, I can tell you, right? But updating the state is strictly managed through a process that I'll go through. And there are different implementations of this Flux-like architecture. One of them, being Redux. One of them being Redux. And the reason that I've chosen to talk about Redux in particular is I've been working with Redux for a year and 3 months on 3 different applications. The reason that Red Badger chose Redux to begin with is it's like Flux, but more functional. And it's all about immutable data, or immutable data structures. And the reason that Redux became like a thing is Dan Abramov, who's a very clever developer, looked at Flux and was playing around with it, and he wanted to have like reproducible state flows. And he couldn't do that when he mutated the state, so he created this version of Flux where you have immutable state, and that's why we ended up with Redux. So, because usually architecture diagrams and flows are boxes of maybe varying colors, I thought I'd make it a bit more fun for you guys. And we got a Lego theme. Yay! So I'm going to thank the Badger designers for this. But these are basically the characters that we are going to have in our Redux family. And they all work together to bring you a beautiful, clean state management system. So first, we're going to have the state. So the state is a JavaScript object. That's literally what it is. It's one very large, well, depending on application, JavaScript object, and everything in your application is in there. Like if you have a user data, the username is in there. If you have products, the product list is in there. If you go really pure and even manage like UI states, so like whether something is open or closed, like toggled open or closed, that can be in there. Like in an ideal world, like that is it, right? And like what you want to get to is that you plug this into your React application, and then one-to-one, you get exactly the same bit, so you can like reflow user journeys if you want. So you can do very clever stuff. So that's our state. And then we have our store. Store is basically like the whole manager for this whole system. The store kind of protects the state. You have to go through the store to get to the state. You have to like tell the store if you want to update the state. You create the state through the store. So it's like, it's kind of like the guardian, the person to make sure you don't do anything naughty. And then you need to get this data from the state to your components somehow. And you know we were talking about pure functional component. So this is an example of a functional pure component. It's just a greeting. It takes in a prop called name, and it just says hello, caddy, for example, or guardian. So what if you wanted to read this name from the store? So notice that our name is in state.user.name, right? So what we can do is we have this function called map state to props, and we get in the state, and then the output is an object which maps exactly the keys that you want to exactly those bits of the state that you need. So like this greeting doesn't care how many products are on a page, it doesn't want to know. All it wants to know is the name. It doesn't want to do user.name, there's no point for that either. So we just have a prop called name, and we say that state.user.name. Then we have some convenience methods from React Redux, like the connect function. And basically we pass in the state of props into the connect, and then connect it around our component. And that's it, connect to the store, it's got the name. So this is basically the read-only part of the state. So we got one state object, one store, and containers which wrap around components. So it's one container per component if you need them. And the amazingly useful thing about this is that multiple components can use the same part of the state without knowing about each other. So next, what if you want to update the state? Having a read-only application is very pure, and we'd like to have that, it would be great. Unfortunately, real life is not like that. So in this example, I am adding an item into a list of items. So basically, the way this works is we have these things called action creators. And what action creators do is they create actions. So, so this is the top bit is a bit of a convention. So you have a type of an action. So for me, the type is add item, right? And then we have a payload which has some information about how to execute the action, like the data that you need. So I want to add an item, and then the item ID is like the ID of the item I need to add. And then you end up with an action, and the action is like basically the result of this function. And then you end up with a type, something, and then a payload with whatever stuff you want. You don't actually have to do payload, that's just a convention again. It's very open to interpretation, this JavaScript. And then finally, we have a reducer. Now what the reducer does is it looks at the action, so it gets the action object, and it gets the state. And then it creates a copy of the state, and then changes that bit of the state that it needs to. So it returns a new state object that's changed the way the action required it. So there's two ways to do this. So one way is using object assign. So if you've not seen this method before, is I have an empty object and then a state object. If you merge them together, that creates a new object. And I'm passing in a third object, which is then the bit of the state that I want to override. There is an alternate way to write this, which I personally use more often, which is like this. There's the same thing. But I think I've looked at the Redux docs recently, and they use this, so I'm going to try to use this as well. Yes, this is a really, really important message. The Redux state is immutable. If you were to do the bit at the top, there is a subtle difference. I'm basically mutating a state and returning it rather than creating a new state object. The way React Redux is set up, like the way it detects changes, it won't actually work. It won't set, the UI won't pick up that something's changed. So it actually breaks your application. So it's not just me being annoying. Right, and the last bit, this is probably the most complicated bit because it's got the most black lines. And this is how I map these actions into my components so that when I call them for my component, the action would get dispatched. So these are the Redux words. So what I do is I import my add item. So that was the action creator from the previous slide. And then I import my bind action creators. That is actually a convenience method from Redux. I can show you how to do that. And I create a new function called map dispatch to props. Dispatch is basically just like a messenger. So it's a function you call with the action that sends it to the store. And then I say, okay, so the prop called onClick, if that gets called, then I want to call the action add item. And then I add it to my connect. So notice that map state to prop is already there. And there's an optional secondary argument, map dispatch to props. So then you can have two. And last thing I need to do is use it in my component. And then I can use it on a button. And then it'll work. Right, so isn't that the best diagram ever? So basically, this here is a pure component. It's got a container around it. And then this container gets the state from the store and the actions, which are created by the action creator. And then together, it has state. And then it can have other pure components as children. But these components don't know anything about the state or props or anything. They just have this parent. So you can have a bunch of these in your application. And then the user gets the website. Yay. So let's look at a very simple flow of how the action stuff works. So suppose the user doesn't like all this color, right? He would like to have a much more whiter component, right? It's too shiny, distracting. So they press a button. Give me white UI. So an action gets dispatched. A reducer gets this action, goes, aha, we need a white UI. Then it looks at the state, makes a copy of the state. Then it changes that state to what the action said it should be, and then returns it. Then map state to props goes around automatically, gets detected. The component with the container gets a new prop, and then its child gets a new layout. That's it. And it just goes in a circle. And it's quite simple actually. Right, so as a quick recap, we have got action creators, which create the action object. We've got reducers, which get the actions and update the correct part of the state. And then the UI gets the updates automatically because we have the wonders of React. Oh no. Right, testing, yay. I do actually love testing. So if you some things are really difficult to test, especially generator functions or async functions or Java. But reducers are actually the most satisfying thing to test in the world. I've done genuine pair programming where I sat with a colleague on a couch with a big screen. I wrote a test, she made it pass. Because they're pure functions, it's actually quite fun. Yeah. So I made this little application. It's really loud. Okay. I made this little application using Create React App. So that was the same thing that Marcel and John used. Sorry. Should start. Oh, right, there you go. So we've got a little, it echoes when I'm close to my computer. It is muted. Okay, sorry. Right, so we've got a little application, and basically all I've added is like, this is like a little Lego store. So you've got 3 Lego bricks to choose from. And then you've got a little basket, which is not very informative, but it will tell you how many items you got. It's got some buttons. We don't do anything because we're going to do that together. And this is what the code for it is. So all I've done, do I need to make it white or is it okay? So all I've done, right, is I got the Create React app, the base boilerplate, and then just added a very, very simple, basic implementation of Redux. So in the index, I've got create store from Redux. Oh, sorry. Create store, which is a function provided by the Redux library. Then provider, which is a thing that wraps around your application, which gives your containers access to the store. And then a root reducer, which is which I'm going to show you what actually it's here. It is in my reducers. So it's very simple. All it does is like just return a state because we haven't got any updates yet. And that's pretty much it. So we got the initial state, like some state that I've decided, okay, I want to start with this. And then I'm going to create the store, passing in the root reducer, initial state, and then this store gets put in a provider, which now means that in any component that's inside here, I can use the connect function and then connect to the store and kind of like get some data in it if I want to. So I've got 2 components here. I've got our basket, which always says like how many items I have. And I've got the connect function from React Redux. And then the map state to props. This is a interesting, maybe, observation. So this basket doesn't actually care like what the items are called or what the IDs are. All it wants to know is how many there are, right? So in the map state to props, I actually say number of items, state.basket.length, right? So because I know it's an array, and it will have a length. And I just connect it, it's got some data. And then I've got a second container, which is the shop container. And then the shop, similar thing, but all it cares about is the products from the state. And I pass it in, just loop over them, and then just show the image. And then what we're going to do later is add an on click here that adds that item into the basket. But just to show you how the Redux state is used. So what if here, like I wanted to like greet me, say, hello, Caddy, you got 0 items in your basket. So, and what if that's in a state? So what I could actually do is I could add it to my initial state here. So I'll call it like user name Caddy. Right? So now it's already there, but we're not using it, so this looks the same. So now in my basket, in the maps of the papers, I can go name, and the name was in state.user.name. And now I can have it in a props. And hello, name. You have items in your basket. Cool. Yay. There you go. That's very easy. So now, like this is the hard bit. Like the updating the state, like getting that right it can be quite tricky. But bear with me. We're going to do it test first. So I've got a test file here already, and the easiest way to test reducers is you define. Well, I'm going to show you. You define the initial state, the action that you're going to apply, and the expected state. These are the 3 elements of testing a reducer. So hit what? I forgot what it's called. To basket. So, Jesus, okay. I'm just going to talk here. So my initial state will be the state that I have with some items, with my basket empty. Actually, I don't even need items. I just like have my basket empty. My action is going to have the type add item, and in the payload it will have the item ID. And then the expected state is obviously like the same state, but with the item ID added. So. It's much more fun when I can talk. State, basket, nothing. And then expected state, basket. Now we got expect statement. Expect, reducer. So initial state. Right, I think I got that right. We've got loads of Redux experts here, so you can correct me if I'm wrong. Oh, I think it's this one. So if you run our tests, where are my tests? Are they here? So, oh no, failing test. So now we can make a pass. So this is the name of the action. So store. Oh, it doesn't actually matter what they're called. This is a convention again. Right. So at the top we got the action name, and then the second thing is the action creator. So that's the wizard, and it will create an action, which is this guy here. And now we can use it. So if we get case add item, what do we need to do? So return object. So we're doing this because we want to create a new state rather than altering the initial one. Yes, state, then state.basket. I think that's right. What did I do wrong? Right. So this, I wanted to do an implicit return, but I forgot to put the brackets around. Item ID is not defined. Okay, because it's in the action. It's part of the action. Action, payload, item ID. Okay, yeah. Thank you. That was so satisfying. So remember, I told you that it's very important to return a new state object, and if you don't, Redux will not be very happy with you. And I can show you later, like what happens in the UI. But before, I can just do it the wrong way here. Right, I'm going to return. So now I'm going to do that state dot basket. This, and then return state. So the test still passes, right? Which is wrong, obviously, because that's not desired effect. So the easiest way to solve this, and it's not the way, is to use a library called deep freeze. All it does is it does an object.freeze recursively, which means that if you go and try to change any of the keys on the object, it's going to throw you an error and make your test fail. So I'm going to show a quick example of that. So I've already imported it here. And then all I need to do is wrap it around my initial state, which is the one that I want to protect. And now if I look at my test, it's failing because, oh shit. I think it's this wire. Okay. Right. I'll try to stand at a distance. Yeah, so now you get an error, a type error. Cannot assign a read-only property basket because you're trying to access something that's meant to be immutable. So now if I go back to my original correct implementation, I'm going to leave this here because I need to demo it later. Now it passes, right? So that's like a quick way to make sure that your tests are correct. Right, so now what we want to do is we want to use this action. We want to hook it up to our little buttons. We want to do it so that if this gets clicked, this ID gets in our basket, and then this number should be updating. Right, you can do this. So it is this one. So in our shop. So what do we have? We had a map dispatch to props function. Const map. And you get a dispatch. Right. And there is a convenience method that you can use, which is called bind action creators. And then you pass it in an object. Click. So this is like, I want to pass in a prop called onClick, and when you click on it, I want it to call a function called addItem. And then it has the dispatch as the second argument. I think this is from, where was that from? I'm going to cheat and check. Redux. Right, so we got this. I need to pass it in here. What is missing? Right, we need this add item. So this is this guy here. So we need to import it. Import add item from up reducer. No. Right. Okay, that would be correct if it was the right file. Right. Yeah, that is correct. Now add it here. So now I would expect onClick to be accessible from here. Then I could add it to the button and go onClick. What do you do? call the onClick with my product ID. That work? Or not? What is wrong?
24.
Oh, thank you. There you go. So close. Right, does this work? Yeah. Look at that. Right, and like last thing, just to prove that I wasn't lying, what I'm going to do is like, I'm going to go to this reducer, right? I'm going to use this other way of adding an item where I mutate the state, right? And I go back, it's reloaded. If I press this button, nothing happens. And that's because the way React Redux is built up, like the React application doesn't see that the state has changed. So that's it is a good thing because it kind of makes you do good practices. Okay. Right, I think that's it for my live demo. Yay, made it. So, before we come to questions, I decided to ask myself some questions that I would ask me having seen this video. First one, a switch statement, right? That's like a lot of people, a lot of devs have been like, what? Like, no, don't want to stick made. That's so 80s. Let's go to using jQuery. Let's go crazy. Right, you don't have to use a switch statement. A switch statement is actually just the easiest way to get across like the way that the state updates happen. The way you implement it is up to you. Like I said, the like flux pattern, as it's called, is an idea rather than like a rule that you have to follow. So for example, if you look at this, the example on the left is the reducer that we used. The example on the right is an alternate way of having exactly the same result. So you can see the reducer is now an object where the keys are the action names, and then they basically map to functions that just take a state and action and return the new state. And then you just like have this extra bit of code, like this tiny bit of extra code, which goes that, okay, so if this type of action is in my reducer, my reducer stuff, then just do it. If not, return a state. So there's no need to use a switch statement. Second one, isn't one reducer going to get really unwieldy in a big application? So if you have like one switch statement or one object, right, and you have a big enterprise application, isn't that going to get really complicated to manage? Yes, of course it will. So there is a handy function called combine reducers. I've stolen this example from the Redux website. But basically, the bit to look at is this. So basically, because this is just an object, right, you can create as many reducers as you want, and they can like have like subchildren. So you can have, for example, user stuff here, you can have a store here, you can have, I don't know, whatever. So like you can map them. Like, and it doesn't even have to be top level, you can do combine reducers recursively as well. And then last, very importantly, what about side effects? We kind of want to do pure programming, functional, mutable, amazing. Unfortunately, in our applications, we have to fetch data, we have to post data, we have to occasionally interact with the window object or document object, which is very annoying. So we need to put them somewhere, right? And there are quite a lot of stuff to choose from. I'm going to talk about these three because I've used them, so I can suggest them. So I put difficulty there, which I mean by like difficult to pick up. But I think that's like I've been told that's very subjective, so take it with a pinch of salt. So firstly, is Redux Dunk, and basically what Redux Dunk does is it's a middleware, and your action creators become functions where they delay dispatching the action. So for example, you dispatch an action saying fetch some data, and then before you actually dispatch it, like you call an action, before you dispatch it, you go and fetch that data, And then you can do another action like with the actual data, update the state, and then you get some data. So that's how they work. It's really easy to pick up. It's good for if you have if you're just getting started, you have a few simple side effects, or if you're just like your first time into Redux and you build a little bit. I wouldn't recommend using it if you have a lot of side effects, a lot of complex, long-running stuff. It's not really good for that. So next up is Redux Saga. Sagas, they are based on ES6 generator functions. If you've never heard of them, they are the hardest thing in the world to test. If you don't already know how to test them. Yeah, they're good though. Basically, the way they work is like the idea of sagas is that side effects should have their own thread. So basically, they're like alongside reducers. So if you dispatch an action saying fetch data, right, both the saga and the reducer get it, right? So you can like do things in response to actions that the reducer also gets, and then, or you can just like do your own thing and then dispatch an action that the reducer gets to update the state. So it is good. I mean, it's arguable. I would say that the initial learning is quite difficult for sagas, but they can be good. And finally, this is most exciting for me, is Redux Loop. Basically, it's really good if your code base is already very kind of FP functional. And basically what they do is they wrap around your reducer, and then just before, it's kind of like you kind of create a new reducer state, but you also do that mutation or like a side effect. It sounds a bit dirty, but it's not. And basically, it's a port of the Elm command architecture. That's what it says on the GitHub repo. So it's Elmy and functional. It's really nice to use. So we're using it at the moment. It's not a plug. I don't work for them. Anyway, so here's some resources. If you want to get started with Redux, absolutely watch the Egghead videos by Dan Abramov, who's the creator of Redux. It is pretty much everyone at Red Badger who started using Redux, looks through those videos, and we're like, that's amazing. Because basically what you do is you build your own Redux. All those magic methods you import, you just implement them yourself and go like, okay, because you do it all the time, we just put it in this library for you for convenience. Really good. Basically, if you watch it, you're like, good to go. There's a cartoon intro to Redux, which kind of compares it to Flux, which has like funny pictures. It's not very useful, but I like the pictures. And generally, the Redux website FAQ is pretty good for any Reduxy questions. And honestly, if you Google Redux Thunk, Redux Saga, or Redux Loop, you will get any of them. So don't need to put a link here. I think I'm done. Thank you.
Does anyone have questions?
I thought I answered all of them.
It's a bit different, but have you used MobX?
MobX? No, I haven't. Sorry.
More questions?
When you answered one of your own questions and you were talking about the combined reducers, do you still have to maintain unique names across all your reducers?
Yes.
Okay.
So yes, but like the easy way to do it is, I don't know if you noticed, but in my example, when I give the add item a name, right, the convention is you have like a lowercase, like something, slash, and then the action name. And then usually like the lowercase name corresponds to the key that you give it in the combined reducers. So that way they'll be inherently unique. And also if you use Redux DevTools and you can see the action inspired in your console, it makes it really easy to see where they came from.
More questions?
This is sort of a general question to the room, but has anyone found a satisfactory like IntelliSense types thing for JavaScript to allow like normal levels of IDE integration? As I see you having exactly the same pain of, oh God, what's each method called all of the time? Yeah, aside from doing it strongly typed.
It sounds like you're talking about something like Flow. Or is it Flow? Talking about Flow? Yeah, Flow or TypeScript. I don't like either. I think if you want a type language, then you should just use Elm. I had a project where we used Flow, and some of my colleagues liked it. I just found it incredibly irritating because you can't ever quite get to 100%, and you have a lot of like extra just code to read. Yeah. Anyway, so I haven't found anything, unfortunately.
Any other questions?
Actually, WebStorm was quite good at some point, and the one from Microsoft, no, yeah, Visual Studio Code. Yeah, they're quite good. Anyways.
All right, I guess that's all. Thank you, Kadi.
Thank you.
Okay, some more announcements before we close. Once again, thank you, The Guardian, for hosting us. Big round of applause to them, please. Also, thank you to our lovely speakers. And if you want to know more about React, come to our conference. It's in March. You can find all the information you need on react.london. Follow us on Twitter. It's at reactlondon_. Yes. And after here, we are meeting in a pub. It's remind me. Star of Kings. Yes, thank you. And that's all. Thank you.